Alright, so here's example 10 for probability. This figure shows a dartboard with a red shaded rectangular area in the middle, as you can see right here. And we also are given the dimensions as shown also right here. Right, let's see part A. If a person is given 3 throws and assuming that person is guaranteed to throw each dart inside the board, so we can assume that there's no way for that person to throw the dart outside of this board, for example to this probably wall on here. Find the probability that the person hits the shaded area exactly 2 out of 3 times, misses exactly twice, and misses at least once. So you can see that this question is a good model for a probability tree diagram. And then for part B, the board was then modified by cutting out the blue shaded regions, 4 of them in each corner right here. So this one is cut it off, this one is cut it off, and so on. Calculate the probability that the person misses exactly 2 out of 3 throws with this modified board. Let's solve part A. Now first we can find the probability here, but notice this is not the usual probability that is defined by the number of ways of that event happening over the total number of ways. Since, well, you can put infinitely many points right here to represent where the dart is going to land, and then the probability will be infinity over infinity, which is of course undefined. So how do we do this? Well, it's pretty simple. We can just express this probability as the proportion of the areas. So it will be the area of the shaded red region, and you can pretty easy find the dimensions will be 30 centimeters times 20 centimeters. So it will have an area of 600 centimeters squared, all over the total area of this board, which will be 90 times 40 centimeters squared, which will be 3600 centimeters squared. This can simplify to 1 over 6. Next, we can draw a probability tree diagram to represent the hits and the possible hits and the possible misses that the person makes here. So this is H for hits, that person hits the area, and then F for that person misses. Alright, so then we can fill up all these leftover probabilities right here. Let me just speed this up. Okay, after that we can determine the possible events that he can hit the target 2 times, exactly 2 times I should say. So the string of the possible strings of events would be he hits the first 2 shots and then misses the third one, or he hits the first and the third, or he hits the second and the third. Now we can just add up all these probabilities for each of these events. So it will be the probability of this event, which will be 1/6 times 1/6 times 5 over 6, and then you can do this for all of that, and with this you leave with an answer of the probability being 5 over 72. Similar way for part 2, which is the condition where he misses exactly twice. So this series of events, or the string of events, will be he misses the first 2 shots and lands the third one, or he misses the first and third, or he misses the second and third. And then we can calculate the total probabilities for each of these events, and then add them up to get a result of 25 over 72. Now for part 3, there is actually a clever way to do this, because let's see, he misses at least once. So we can say misses at least once for this event. Now instead of desperately trying to find all string of events that satisfies this criteria, we can actually use the complementary, or I would say the probability complement property. So that would be 1 minus the probability of the complement of this event, which is that he hits all of them. Which makes sense because if he doesn't miss at least once, therefore he must miss none of them, or in other words, he hits all of them. So therefore, this is pretty easy because we can just calculate one probability right here, which is this one right here, which will be 1 over 6 cubes because there are 3 1 over 6's, which will be 215 over 216. And then for the modified board part. Now for this, we can do the similar trick to find the probability of hitting the target for one throw. So it will be the proportion of the area of the shaded region, I should say the red shaded region. And this time, the total area of the board will be the area of the original board minus the subtracted areas of the board. And it is pretty easy to see that all 4 of these cut it out rectangles are actually congruent. So we can just take 4 times the area of each of these rectangles, and those rectangles have a dimension of 30 centimeters times 10 centimeters. So that's pretty easy to get as well. So this will be 4 times 300 centimeters squared, leaving us with an answer of 1/4. The probability is more common in this case. Now similar case for part B, we can again draw a probability tree diagram right here, and I'm just going to skip that step. It has the similar ways or similar methods as the part A. You can just find all possible string of events that satisfy this question criteria. Note that order does not matter in this question's criteria, and then you can sum up all the probabilities for each of those string of events. So I'm just going to skip to the answer. Our answer will be 27 over 64 for part B. And this ends this video.